Algebra 2 Honors, 14.6 double and half angle formulas. So there's more formulas. If you want to see them derived, you're going to have to look somewhere else. The interesting thing is that we have a double angle 2 times for sine and cosine. Tangent's not involved here. There is a tangent double angle formula. We're not going to get into it. But the interesting thing is that there's only one formula for sine and 3 for cosine. And they all work. It's not really a problem. Going to be a little tricky here with me going up and down with the formulas on a different sheet, but I'll do the best I can. The first thing you do, though, is find sine, and then you need cosine of theta for the original angle. So notice this is sine of theta, cosine of theta, cosine of theta, sine of theta, so on and so on and so on. Whereas what we're trying to find is sine of the double angle. So you have to do all this from 2 different perspectives. The angle itself being in quadrant 2, sine of theta is 4 over 5. It's a 3, 4, 5, but we're in the second quadrant, so the x value is negative. Cosine of theta, therefore, equals negative 3 over 5. And this is used to find sine of 2 theta and cosine of 2 theta. I find the sine of 2 theta formula easier to use. It's just 2 times sine of theta cosine of theta, so 4/5, negative 3/5, which is negative 25/5. There's only one formula, and that's the only one you have to use. For cosine of 2 theta, the formula is easy enough to use, but just the fact that there's more than one seems confusing. So we're going to use the top one, cosine squared minus sine squared, and I'll try and show you how it doesn't matter. So that would just simply be negative 3/5 squared minus 4/5 squared, 9/25 minus 16/25 equals negative 7/25. Or we could do it. And since we were given sine of theta, let's use a formula that just has that in it. 1 minus 2 sine squared theta. 1 minus 2 sine is 4/5 squared. 1 minus 32/25, which is negative 7/25. Works either way. Notice on this one, the positives and negatives all work out on their own. You do not have to try and keep track of them. That's it. These formulas are not hard to use, but they are very confusing. Be careful. I believe I've made this a plus over here by accident, so make sure you have the correct formula in your notes. So, same thing. Sine of theta, quadrant 3. And I gave you ugly one. I gave it on purpose, and this is going to get very ugly. If it's a triple, it works. Notice this is not a triple. It's negative 3 over here and 4 here. If it was 5 there, we'd have a chance, but we do a little of Mr. Pythagoras. We find negative root 7. Get 7 and 9 is 16. Yep, that works. Don't forget the negative. So cosine of theta, which is all we need for these formulas. It's cosine of theta here, cosine of theta there. And these are half angle formulas. We just did double angle. Now we're doing half angle. So we look at plus or minus, because at some point during the derivation we must have taken a square root. 1 minus cosine of theta. Oh, actually, I'm doing the half angle formula. Let's go over here and just say cosine of theta equals negative root 7. Cosine of theta equals negative root 7 over 4. 1 minus negative root 7 over 4. Now I'm going to do the algebra relatively quickly, so watch carefully. You can pause it and rewind it, but it's all just basic algebra from here. Going to turn the 1 into a 4 over 4. Going to bring the 4 down, make it an 8. Going to break the radical to top and bottom. Going to make the bottom 2 root 2. Can't have a radical on the bottom. Got to rationalize. This is where I usually lose people. Bottom, no problem. Root 2 times root 2 is 2 times 2 is 4. Root 2 times 4, well, now it's inside, so it's actually 2 times 4, 8. Now it's root 2. No, it's 2 in front of the root 7. Extremely complicated math. Notice we haven't said if it's positive or minus. We're in the third quadrant for theta. If we're in the third quadrant for theta, half of that puts me right here. So theta is in here. Theta over 2 must be in here. We could just easily use SOHCAHTOA to figure out what theta is and go from there, but this is one of those half-angle formula things we do. Helps us when we get to integration and things like that in trig. So, second quadrant, we're looking for cosine. It's negative. So I'm going to get rid of this and just put negative here. If we did the sine formula, it'd be positive because we're in the second quadrant for theta over 2. Confusing, complicated stuff. So a lot of people look at this and say, oh, why don't we just do sum and difference, 60 plus 45? I say, no, that's not what we're doing here. We're doing half-angle formulas. We could rewrite this as 210 over 2. Now it's sine of 105. We know that's going to be positive. It's sine of a half-angle formula, so if you go all the way back up, it's a negative in there. And this is the theta. So 1 minus cosine of 210. So cosine of 210 is negative root 3 over 2. We just did a lot of this before. Done. If you're not sure what I did there, just follow the steps like we did last time. It's not that complicated. Cosine of pi over 8 is like saying cosine of pi over 4 divided by 2. So this is our theta. So we're in the first quadrant. It's positive. Square root of 1 plus cosine of pi over 4 all over 2. And now we're off to the races again. So those are double angle and half angle formulas. That's where trig gets really abstract, really hypothetical. So do the best you can. Good luck.